Number 5, a gas at 155 kPa and 25 degrees Celsius has an initial volume of 1 liter. The pressure increases to 605 kPa as the temperature is raised to 125 degrees Celsius. What is the new volume? So it's a trapped body of gas undergoing changing conditions. So that makes me think the formula to use is P1V1 over T1 equals P2V2 over T2. Let's see, it says the initial pressure is 155 kPa. The initial volume is 1.00 liters. The initial temperature is 25 degrees Celsius. Pressure 2 is 605 kPa. Volume is what we are solving for, and T2 is 125 degrees Celsius. When you are using this equation, it doesn't matter what you measure pressure in, it doesn't matter what you measure volume in, so long as it's the same on both sides. Because this is really a proportion, not strictly speaking an equation. Temperature, however, has to be in Kelvin. Anytime you work a problem with gas laws, temperature always has to be in Kelvin because it has to relate to the molecular motion. It does not relate to the boiling and freezing point of water. So 25 degrees Celsius, you got to add 273 to that to get 298. 125, you got to add 273 to get 398. kPa, kPa, they match. Since this volume is in liters, then V2, when we solve for it, is going to come out in liters as well. Now, I would like to see this equation rearranged before you plug numbers in, so you can cross multiply and rearrange that formula into P1 V1 T2 equals P2 V2 T1, and then we want to isolate V2, so we're going to divide P2 and T1 over to this other side, and so we end up with V2 equals P1 V1 T2 divided by P2 T1. And then plugging in the numbers, it's going to be 155 times 1 times 398 divided by P2, which is 605 times T1, which is 298. And so plug that into a calculator. V2 should come out to be, all right, 155 times 398 divided by 605 times 298. And I get 0.34217. Looking back to the original problem, 3 sig figs, 2 sig figs, but then you add 273, so it's technically 3 sig figs, 3 sig figs. In my answer, I'm going to keep 3 significant figures. So I'm going to say V2 equals 0.342 liters.